Welcome to the engineering training for our bold approach to our project's business. During this course, we will discuss our new organizational structure and where engineering fits in the Zone Technical Center, the Shared Design Tool Database, new tools we will leverage to support the changes to our business, the automation engineering standards for submittals, and fire engineering standards. As part of this digital transformation, our designers are now centralized as one team to serve the entire zone, reporting to an engineering manager responsible for all project engineering regardless of product line. With these changes, the design team will provide resources and expertise to all offices in the zone. To achieve smart project delivery for our customers, it is expected that everyone follows standards and our productivity toolsets are integrated into the way we work. There are several tools that the engineering team will utilize. Let's start by talking about the common database that all design tool users will be linked to moving forward. Currently, the design tool product database is stored locally. If that database is not updated or maintained regularly, designers run the risk of not having access to the latest products. In addition, if the database differs by team member, the team is not able to work on a project simultaneously. With our new approach, all team members will work off one common database unique to the zone. This database allows multiple users to work on the same project simultaneously and ensures the team is working with the most current product database available. To ensure you are working with a common database, you will need to make changes to your setup in Design Tool. To do this, click on File, then Options. In the Options window, you will need to make changes to the SQL Server Machine, Products Database folder, and the Order Systems folder. Please take a moment to pause this video and capture the changes displayed on your screen now. Once you have made these changes, click Apply and then OK. These instructions are also available in the Building Automation Detailed Design folder inside the Smart Project Delivery Guide available in Bluebeam. The other tools that we are enabling to support our new approach are a Zone File Share, Bluebeam, PMCT, and Rike. In addition to Rike, designers will leverage the Zone File Share in Bluebeam. Zone File Share replaces the K drive that designers used previously. It is a single place that the project-related engineering files will be stored. Bluebeam will be used as a workspace for design drawings and submittals, and ultimately is the vehicle to deliver the Digital Deployment Package, or DDP, to the branch. Bluebeam will contain product plans and specifications for reference. Designers will add their drawings to the tool for use by the specialists. Once the project is complete, the drawings are incorporated into the operations maintenance manuals delivered to the customer. The Zone File Share will ultimately house the documents altered in Bluebeam. It is the designer's responsibility to maintain all the record files in the Zone File Share. Detailed Bluebeam tutorials can be accessed in the Smart Project Delivery Guide. BT has standardized our submittal requirements for building automation systems. These new standards focus on two areas: the sections within the submittal and what is required to be included in the sections. During this training, we will be covering each of the standards within the submittal. Submittals are separated into 6 required sections. Please note, it is not intended that every section be completed at the same time. For example, schedules and control drawings can be added to the submittal earlier than panel layouts or vice versa based on project priorities. The report section will be completed after commissioning activities have been finalized. The first section is where the equipment schedules are included. All of our submittals are to have completed equipment schedules. This section is required and is where you will find valve, damper, airflow station, flow meter, VAV box, variable frequency drives, and other equipment provided by Siemens. The report section is reserved to include the various documents produced during installation and commissioning. Some examples are point summary reports, PPCL and commissioning reports which have been completed. Documented results of startup activities are to be included. This is also where you include reports created by the commissioning report generator for automation projects. The control drawing section will include the drawings created during project engineering, such as system risers and typical systems. It is to also include diagrams that are needed to install the control system and depicts the wiring which is common to a number of devices. Examples of this are VAV boxes and fan coil unit wiring diagrams. In this section, there is a detailed numbering scheme which is to be adopted. There are dedicated numbering standards that apply to riser, ventilation, cooling plant, and other systems. The standards numbering schemes are shown here. Additional details can be found in the Smart Project Delivery Guide. The details of the numbering schemes are outlined in the System Numbers section of the Automation Engineering Submittal Standards. The panel layout section is to include the fabrication diagrams needed to mount and wire all hardware to operate a system. In addition, the drawings show the mounting, assembly, and wiring of our products and provide the subcontractor with instructions on how to terminate field wiring. The wiring diagram section is reserved for standards and typical wiring layouts that are not covered by the other sections. Section 6 of the submittal will contain all technical literature for Siemens provided material. Original versions of technical information are to be inserted here. Typically included are cut sheets which detail products, technical capabilities, and specifications. In addition to the required layout of the submittal materials, there are defined requirements about our design practices. These requirements are outlined in the Engineering Submittal Standards for BAU policy. It is each employee's responsibility to review and comply with the BT standard engineering practices outlined in this policy. This policy can be found in the BT Document Management System and is made available to you in the Smart Project Delivery Guide in Bluebeam. The engineering policy is required to be reviewed at the conclusion of this training. It is your responsibility to include these design requirements when designing a system. The detailed fire alarm system design procedures have been established for a number of years. These required design practices have not changed. It is your responsibility as a designer of fire systems to review these requirements and incorporate them into your system designs. There are 4 policies you are responsible to know. The BT Fire Alarm System Design Engineering Procedure, the BT Fire Alarm System Engineering Submittal Procedure, the BT Fire Alarm System Engineering Drawing Standards Procedure, and the BT Fire Alarm System Engineering Codes Compliance Procedure. These policies can be found in the BT Document Management System and are made available to you in the Smart Project Delivery Guide in Bluebeam. These fire engineering policies are required to be reviewed at the conclusion of this training. In addition to the engineering standards we just covered, there are 2 tools expected to be used to engineer fire projects. Let's start with CAD Advance Plus. CAD Advance Plus eliminates many repetitive tasks. All fire alarm project designs are to provide the following required outputs: auto-addressing of devices, export of initiating devices. Designers are to provide this export to the programmer for their use, and completed voltage drop calculations generated by CAD Advance. If you do not have CAD Advance Plus, installation requests can be submitted to the email listed. The second tool that all designers are required to support is TAP. The setup and use of TAP is a requirement for all fire projects. The technical coordinators will configure TAP, and then it is the responsibility of the design person to load the design drawings to the TAP server. Uploaded design drawings allow field team to control the panel from a phone, perform remote troubleshooting without running back and forth to the panel, ensure data logging for reporting, markup layouts in TAP to include all as-built conditions, locate devices quickly, and keep track of tested or non-tested devices. The following reports are to be generated using TAP: NFPA Record of Completion, NFPA Record of Inspection, and Device Pass Fail Report. It is the responsibility of the design engineer to identify material that is to receive a product promotion discount. If not maintained properly, the project will be charged full price. There is a dedicated 40-minute training that explains the process. It is mandatory that each fire engineer complete this additional training. It has often been discussed that fire designs cannot be completed by teams not locally based. To address this concern, there is a required local codes library to be maintained within each zone. Typically, fire engineers are geographically located and know the local requirements. It is standard that each zone has a SharePoint library to maintain local code requirements. Each jurisdiction has a designer assigned the responsibility to maintain this reference. Additionally, the Code Finder application available from NFPA can be used to review the requirements of each authority having jurisdiction. By following these standards, adopting new workflows, and utilizing new tools, our project teams will be enabled to provide smart project delivery to our customers.